So another thing I can do for you, I can give you a test, but I won't mark that test. Your lecturer, when he comes or she comes, she will mark your test. So if your lecture is not here by the end of this week, that will mean next week, Tuesday morning, you will be writing your first test based on the theory, the 3 chapters theory, which is chapter number 1, workshop layout, also corrosion and bearings. That one is a 30% of your final year mark, those 3 chapters. So if you do not have a new lecturer by Friday, know that Tuesday you are writing your test 1 based on this theory, meaning the test 2 will be only calculations. If your lecturer is here before Friday or by Friday, it means he will guide you what to do. Chapter 2. Belt drives. What's the function of a belt drive? What's the function of the belt drive? Sorry? 2? Belt transmit power, ne? Belt transmit power. Power is equals to TE times V. Belts are there to transmit power through the belts. So, here is the connection. This is your pulley. This is another pulley. Here, you connect these 2 pulleys by a belt. You connect these 2 pulleys by the belt. So, if this pulley is the one who rotates first, or is the one which is connected to the motor, and is rotating to this direction, between side A and side B, which side will be tight? Side A will be tight, ne? Yes. Remember, this one is stationary. So as this is stationary, this one starts to move. When this starts to move, it means it will pull this belt. As it pulls this belt, the belt will pull this one. So this A, it will become tight. This B, it will be slack, ne? So let's take, for instance, it rotates to the opposite direction. It rotates to that other side. Between side A and side B, which side will be tight? Side B will be tight, ne? And side A, slack. So what you must know is, on the tight side, in this case, on the tight side, you'll find your T1. On the slack side, you'll find your T2. Always On the tight side, you find T1. On the slack side, you find T2. So therefore, TE is an effective tension. For you to find that TE, you must take T1, you subtract T2. Then you will find TE, effective tension. You understand that part, ne? So the aim is to transmit power, which is effective tension times velocity. So now let us talk about velocity. Do you know a difference between angular motion and linear motion? Sorry? What's the difference? Sorry? Linear to do with horizontal. If I go up, it cannot be linear. Or if I go vertical, it cannot be linear. Sorry? So angular motion, it will be having n, and is in radius per second. So V, it will represent linear in meters per second. So linear is to move from one point to the next point. You understand me? If I move from there to the next point within a certain distance, that is linear. So angular, it has to rotate with a certain radius. You understand that one? Eh? So here, it's a linear speed. It's a speed of the belt. If you can check, the pulley, it rotates with a certain radius. Even this one rotates at a certain radius. But the belt, if you mark the belt here, and you start rotating this one, this belt is going to move from that point and cover a certain distance to that point. Then now it turns. Can you see? It's not rotating at a certain radius. It moves. So, okay, how do we calculate velocity? How do you calculate velocity? What's the formula to calculate velocity? V is equals to pi effective diameter times n over 60. This is how you find your velocity. So, let us talk about dE. dE is an effective diameter. dE is an effective diameter. So without wasting time, what I can say, if you are using a flat belt, I are using a flat belt here. If the cross-sectional area of this belt is this one, cross-sectional area meaning when I cut here and view from this direction, what I will see is this one. I have cut the belt. This belt goes like that and tear. So this is the cross-sectional area. So, as you can see, it's flat. Meaning, to calculate the effective diameter when you are using a flat belt, it will be the diameter of the pulley plus the thickness. That is how you get your effective diameter. If you are using a V belt, your effective diameter is the diameter of the pulley. You You understand? Eh? If you are using a V-belt, the cross-sectional area here, it will be something like this one, which it forms a V. Then it goes to the pool, it turn about the pool. So that cross-sectional area, that is the one which is V. So if you are using a V-belt, your effective diameter, it will be the diameter given of the pulley. You understand that one? Eh? So N is the angular motion of the pulley. Angular motion of the pulley in radius per minute. That is what down there we have 60. If your angular speed is in radius per second, it means your formula must not divide by 60. You understand that part? Okay, so we are having two pulleys here. We have this pulley, pulley number 1 and pulley number 2. Which effective diameter is this one? Is it for pulley number 1 or pulley number 2? Which effective diameter is this one? For pulley 1 or pulley 2? Pulley 1. And this the speed 1. So what you must know is, if you use the effective diameter for pulley number 1, even the speed you must use for pulley number 1. You understand that one? Eh? Yes, the rotation, pulley number 1, even the diameter, pulley number 1. If you use pulley number 2, therefore the effective diameter you must use for pulley number 2, and the rotational speed you must use for pulley number 2. So doesn't matter, you use this one or you use this one, you must get the same answer. Meaning when calculating velocity, if you use pulley number 1, you must get the same velocity as from pulley number 2. So okay, we said velocity is pi effective diameter for pulley number 1 times angular speed for pulley number 1, all divided by 60. All this one must be the same as pi effective diameter for pulley number 2 times speed 2 over 60. If you check, 60 and 60 cancel, pi and pi cancel. Meaning at some other point, you must always remember that d times n is equals to d times n. But this one for second pulley, first pulley. This one, you must always know it. You can also change in your textbook, because in your textbooks, here it wrote plus. If I'm not mistaken, just check there. You must write equal sign. So now let us go a little bit deeper with the tension. We said the side where it's tight is always where we find our T1 in it. So between T1 and T2, which one do we find a maximum tension? Sorry? T1, eh? Remember T2. T2, this side is slack, ne? Meaning the tension, this side is very small. Whereas this side, yes, the tension this side is higher. So if this belt, it was not strong enough, between side 2 and side 1, which side is going to tear? Side 1 is going to tear, ne? Meaning this side is where we find our Tmax. This side is where there is Tmax. Therefore, we can say T1 is equals to stress times area. Stress of the belt times area of the belt. That is T1. And they see T1 is the same as Tmax. T1 is the same as Tmax. So, usually, your Tmax, you'll be given as Newton per meter. So, if you are given it as Newton per meter, that is your T1, but it's in Newton per meter. What you must do is to remove the meter. How do you remove the meter? How do you remove the meter if you are given Newton per meter? Sorry? Agreeing Newton per meter is the same as Newton over meter, right? Therefore, for you to remove this meter, you must multiply by meter. So meter and meter will cancel. If you are given Newton per millimeter, that will be the same as Newton over millimeter. Therefore, you need to multiply by what? Millimeters. So that millimeters and millimeters will cancel each other. You understand that part, ne? Once you are able to cancel this meter, now it's T1. You understand, ne? Yes, once you're able to cancel that millimeter or meter, now it's your T1. So, this meter, it's a meter of what? Or this millimeter? Is it the length of the belt? Or is it the thickness of the belt? They will tell you it's a millimeter of what? You understand? Eh? The question will be specific. That this is a millimeter of what? So this one, remember, force is equal to stress times area. This one is in Newton, even force is in Newton. So therefore, that is why even T1 is stress times area. So now, let us look at area, because this is a stress of the belt. For your understanding, I can say stress, we are looking on how strong is the belt, for your understanding. But it goes deeper than that. So area, of course, is the area of the belt. Area is the area of the belt. If you are having a flat belt, the area will be a width multiplied by a thickness of the belt. That will be your area if you are using a flat belt. But if you are using a V belt, your area, this one will be given. For V belt, the area will be given. If the area is not given, you know this is a V, that is V. You know mathematics. You can come and construct there, and you construct there. You calculate area 1, you calculate area 2, you calculate area 3. The total of this area, it will give you the area of the V belt. Should it happen that you are not given, but always you are given. So this one, foreign case, we never know. Things change. So if you're not given, that is how you calculate. The first one is a triangle, which it will be half base times height. This one's a rectangle, which will be b times height. This one is a same triangle as that one, meaning this one and this one, you can just multiply it by 2 because they are the same. So that 2 and this 2 cancel each other. You have base times height plus base times height for this one and this one. And when you add them together, you can say it's 2BH. Should it happen? But this one, you are usually given. So, we also have T1, T2 ratio. T1, T2 ratio. T1, T2 ratio is equals to E, contact angle, coefficient of friction. This one is under a flat belt. So this theta is a contact angle where the belt is in contact with the pulley, is that theta. This one is a coefficient of friction. Remember, if this belt is not tight enough, the pulley can rotate alone, meaning there is a friction happening here, there, one way or other. So you need, the higher the friction, the lesser the slippery of the belt. So this one, this angle, you do not substitute it in radius. No, in degrees, you must substitute it in radius. Do you know how to convert it? Yes. So for V belt, T1 over T2 is equals to E over sine alpha. This angle, we said is a contact angle in radius. Ne? This one is the V belt. Is the groove angle, half groove angle. If you check a V belt is this one. There we have a groove angle. So half, it means you only use this one. So with this one, you must always use a half groove angle. Meaning, if they say your groove angle is 40, which angle to substitute here? It's 20, right? Yes. And this one is in degrees. So, okay, it does not end here. Some other times when you check the textbook, you find that they are subtracting TC. Do you know what is TC? What's TC? Sorry? COVID. Centrifugal tension, eh? Centrifugal tension. Do you know what centrifugal tension? Okay, let us start by centrifugal tension. Yeah, this is a quantum. The driver is speeding and you are approaching the curve. And this driver is not slowing down. And somehow he managed to turn here. What will happen to the passengers inside? Sorry? As they turn here. They will all move towards this side. Ne? It might also happen that even himself, he cannot able to turn here. It might find that he end up going somewhere that side for him to turn. What makes this taxi or the passengers to go to the other direction? That it has to do with centrifugal force, ne? Yes. That is why you will never find this taxi or the car. If it rolls, it will never roll this side. Once it rolls to this side, you must know that God was no longer there. Only the other God was there. It will only roll to this other side because of a centrifugal tension. That is why some other roads at the curve, you find that the tire road is not flat, but at a certain angle to overcome this centrifugal force. Same applies on the belt. Here you are having your pulleys. This is rotating, and this starts rotating fast. This starts rotating fast. So if this belt is not tight enough, you will start to see this belt it won't be on contact there. It will start to leave the pulley. Agar is going to that direction. Now when it gets here, it starts to turn. The centrifugal force, it will want it to continue to that side, but it cannot able to. Or centrifugal force, it pulling it to that other direction. So therefore, your centrifugal force tension, it will be mass of the belt in kilogram per meter times the velocity of the belt. This one, it will give you centrifugal tension. So for your syllabus, the only time you consider centrifugal tension is when you are given the what? The mass. Do we still have time? What time does this paper end? We still have time. How many minutes? 18. Okay. So, okay. You will only consider centrifugal tension when given the mass. And if given the mass, therefore, your T1 over T2 ratio changes to this one. The other one under V belt. Over sine alpha. So it's only cosec if this one you multiply it in. Yes. Open on page 20. Can you see on the figure there? And page 22. Okay, page 22 and page 24. Page 22 and page 24. Page 22, the belt is connected in this manner. Page 24, the belt is connected in this manner. So this first connection, this one, it's called open belt. Ne? So for open belt, you can connect flat belt. You can use flat belt or you use V belt. This one, you use V belt. No, you use flat belt. You use flat belt. With this one, it's a flat belt. This one is a flat belt and a V belt. For your slappers, what you need to know from these two is to how to calculate the length of the belt under open belt and the length of the belt under cross belt. The formulas that are there, page 24, you will find the formulas. So, we do not have time. As we are not having time, you will take this exercise home. Page 40, exercise 2.1. You do number 1 up to number 5. Number 1 up to number 5. So tomorrow when you come, we will solve the question based on what we know. If you did not write, it means you won't be welcome in the class. I'm not saying go and write and find correct answers. I'm saying go and write according to your understanding. You understand that, ne? Yes, so go and write according to your understanding. Lastly, create a list of you guys. I'm not going to collect it from that other side. You write your name down and initial. Your surname and initial plus your ID. So that when I give the test, I will only give the test to those whom I know. Should it happen that I give you a test? So please go try to solve and check if there's something in which you have to misunderstand tomorrow.